Great. Well, welcome everyone. My name is Tim Anderson. I'm from White Labs in Copenhagen. I've been with White Labs for about 6 years doing sales and customer service for all over Europe. Also doing some production planning, and so I'm pretty deeply involved with all aspects of the business. So it's nice to be here today. Let me see if I can get this thing to work. There we go. So I'll do a brief introduction to White Labs. I'm going to talk a little bit about dry and liquid yeast, a little bit about yeast in general, and choosing the right yeast. There's going to be plenty of time for questions and comments, so I can potentially go a little different direction if people have some particular wishes. Personally, I do most presentations to professional brewers, but I have spoken a bit to home brewers. We just started producing homebrew in Copenhagen last year. Previously, it all came from White Labs in San Diego. So it's nice to be on this side of the business as well as the pro side. So I'll just quickly talk about White Labs. It was started in 1995 by Chris White, hence the name. He did a PhD in microbiology and yeast and started homebrewing, and basically the demand grew from there as his homebrew circle grew and people heard that he was producing yeast. He started producing more and more, and it became professionalized. These days, it's about 90% professional business, 10% homebrew, so kind of different from 1995. We also produce, there's a lot of different yeast bacteria, enzymes, nutrients, a lot of education, which you could count this as some of that, some even more formal, also for pro brewers. We have production facilities in San Diego and Asheville in the States, and since 2014, we've been in Copenhagen. I'll talk more about that in a minute. We also have a tap room and a restaurant in San Diego and in Asheville, if you've ever had the fortune to visit there. People love it. So White Labs Copenhagen is started in 2014. Since 2018, we've been in our current location, and we'll be here for the foreseeable future. We've greatly expanded the production capacity since really 2018 was the real takeoff point where we could really start expanding the business. We became fully organically certified in 2019, so everything produced by White Labs Copenhagen is actually organic. There's really no business case in it. It's not that people are demanding it, it's just we felt it was the right thing to do. So from the start, we always produced organically. And at the moment, we're producing over 70 strains, both in professional and homebrew format. And as I said, supplying the entire European market. So the thing about White Labs is that differentiates White Labs from a lot of the other producers and certainly dry yeast is the production process, which I'm not going to go through it in detail, but the short summary is that whereas traditionally yeast is produced in something that looks a little bit like, fermentation tanks, we actually use large plastic vessels, and until recently those plastic vessels will become part of the final package. So basically they would get sealed off and chopped up. These days we still use the same process, but we pump into our new packages instead, which gives, there's some benefits to the new packaging. The whole yeast production or propagation process, if you prefer, is approximately 21 days. So from a few cells on a plate on day one, and then through a step-up process through the lab, and then on to the big machines, and then the final vessel is about 400 liters, and that's going to produce around, give or take, 20 liters of finished product. Our yeast is very concentrated, so some producers, if you've ever been in a professional brewery, and they'll say, oh, we bring in the yeast in big containers, but ours is concentrated, so basically that means you take off all that supernatant from the top of it, and then you're left with a very concentrated slurry of about 2.15 billion cells per milliliter on average, if you're into cell counting and that sort of thing. We also do a lot of nutrients, like zinc being very important. I'll talk about that. Other yeast nutrients. Enzymes, not so relevant in the homebrew setting, but becoming more and more of interest to homebrewers. And I'm sure some of you have explored that area as well. So I'll talk a little bit about dry and liquid yeast. So White Labs traditionally has been a 100% liquid yeast producer. The production of liquid yeast is very different from dry, but recently we've started, you may or may not have seen, we have 3 dry strains now, WLP001 California Ale, 066 London Fog, and 860, which is a Munich lager. We use Lallemand to produce that yeast. It's been a 10-year project getting dry yeast off the ground, and the main reasons for that was that we simply couldn't find well, there was a few things, but the key point was we couldn't find a producer that could hit the quality standards that we wanted, which means being able to maintain the flavor profile of the yeast, which was actually number 1, followed by a very, very close number 2, which is just the quality level, the QC level, which is like the contaminant level, which I'll talk about in a moment. And the nice thing about, so traditionally we've even though we've been a liquid yeast producer, we've never really taken a position on, well, should you use liquid or dry? We've been very neutral about just saying, well, this is the benefits. So now that we're actually producing dry, we can tell you that liquid is much, much better than dry, even though we're actually selling dry. Which is not to say that dry doesn't have many, many advantages. So I'm just going to run through quickly a few of the key points, and I'm gonna preface this by saying that as a home brewer, and I was a home brewer back in the day, and I don't really have much time for it now, but I'm sure I will return to it. If I had to, I don't think I was a very good home brewer, and I think the reason for that was that I didn't respect or understand the importance of 2 things, and if I could, if you could take away 2 points from today, it will be this. Focus on temperature control. We'll come back to that. And you will never be able to, in spite of all the best equipment and ingredients and so on, dry yeast will only take you to a certain level. Spending that few extra euro on liquid is really gonna do something. There's obviously, that's a very, very simplified, very simplified way of saying there's 2 key points, but the temperature is really something, and I'll come back to that. So dry yeast, not all yeast strains can be produced in a dry format for various reasons. They simply don't go through. It's a very stressful process, and some of them just don't survive that. Liquid, more or less any yeast strain can be produced in a liquid format. Flavor, again, that's not to say that there aren't very good dry yeast strains. There are. There's also some that are not so good, that really their flavor is very muted. But in general, you will always have a more muted flavor profile compared to a pure culture that has, high viability and all of that. Quality control is a really interesting point, and this is something that probably you may or may not know, but you can't. First of all, if you actually take a slurry of dry yeast and look at it in the microscope, that is the actual yeast before it's been through fermentation, you'll see it in the dry format. There's no such thing as a pure culture, and it says that, not in those words, but it says that on the package. It has a very high purity level, but there is other strains in there. So when you do your fermentation, there's always going to be something else going on, and it's usually a Saccharomyces strain, so it's not normally wild yeast or bacteria. It's not a contaminant as such, but it's not a pure culture, and that will impact the flavor profile. And you can actually, on the package, it will say measured to 1 to 1 million yeast cells, so meaning that there'll be less than 1 contaminant per 1 million yeast cells in a dry package. In a liquid package, and I can't speak for other liquid manufacturers, I can speak for White Labs, you can actually measure that in terms of wild yeast and aerobic bacteria to the level of 1 to 40 million yeast cells, so an extremely low level or potential level, let's call that, of contamination. And for anaerobic bacteria, 1 to 140 million. So you can see that when there's no such thing as a truly pure dry culture, but there is what is essentially a pure liquid culture. That is possible. So that's a big difference. And if you're into harvesting and repitching your yeast, which some of you might have tried, that's where that even comes into play even more, because there'll be a certain drift over time, which I just said about repitching. Shelf life, of course, that's a huge advantage of dry. We all know it. Most dry yeast has 24 months on the package, and in reality, it can last a lot longer. Normally, easily 36 months, and honestly, it can probably last even longer. So it holds its viability very well, which is fantastic, especially if you are able to keep it refrigerated. Liquid is, of course, the opposite. It has typically a 2 to 7 month shelf life, and again, it's strain dependent. Some strains can actually last a bit longer, but and some strains are struggling at 7 months. So that's a big disadvantage, and you have to keep it refrigerated. You don't have to keep dry yeast refrigerated. Flocculation, again, probably something that's more relevant in a professional brewery setting, but not irrelevant in a homebrew setting. That dry yeast, because of the way the drying process affects the yeast and the cell membranes, sometimes it can have a negative impact on its ability to flocculate out, which of course is what you want right at the end of the fermentation. That is why brewer's yeast is brewer's yeast, because of that ability to flocculate out. That's why there's plenty of other yeasts out there, but they're not used in a brewing setting because they don't have that capability of flocculating. So, a little bit about choosing the right yeast strain, and to be honest, there's a whole lot of topics under this big umbrella. So, yeast is a single-cell organism, as you probably know. There's something like 1,500 species of Saccharomyces cerevisiae that have been identified, and tons more that are not that. It's in nature, it's everywhere, it's in this room, it's outside. The thing about yeast that is probably underrated both by homebrewers and professional brewers is the incredible impact that it has on flavor. And these are numbers that some of it you can put a scientific grounding on it, and some of it is a little bit harder to say. Is 59% of aroma, what does that mean? 79% of flavor being contributed by yeast, what does that mean? But what you can say, you can identify different flavor and aroma compounds if you look at it. So that is absolutely true. And obviously, depending on what strain you're taking, you're going to have significantly different flavor profile. And I would dare to say that the one thing that you can put in a lot of expensive, lovely, fresh or less fresh hops. The same goes for malt. But the one thing that you can't ingredient your way around is yeast. And that's why I said at the beginning, especially if you've invested all that money and time into doing a brew, that few extra euro on a fresh, pure, liquid yeast culture is going to pay off, because there is so much of that flavor that's derived from the yeast in the finished product. And of course, it's less so if you're, say, comparing an IPA, an ale yeast that you're using in an IPA versus a yeast you're using in a Hefeweizen. Obviously, there's a massive flavor difference, and a much smaller one compared to IPA yeast strain A or IPA yeast strain B. But the difference is still very significant, and you can see that if you ever do some side-by-side sensory testing with the same batch fermented with different yeast, you can very, very quickly understand the role that yeast has. Oop, going the wrong way here. So, I don't know how many of you are familiar with a curve like this, but this is what happens in any given fermentation. So basically, on the bottom here, you've got number of days from day 1 to day 6. And typically in an ale fermentation, you're finishing up around day 4, 5, 6. The bulk of the fermentation is finished. If it's a lager fermentation, it's a bit longer. It's about day 8 to 10 typically, assuming that all the variables are as they should be. And I'll try to talk a little bit more about that as the presentation goes on. But just to talk about what we're seeing on this curve. So you can see on day 1, if we start with well, first of all, the dark blue line here, obviously there's no ethanol, there's no alcohol that's been produced, and then as the fermentation goes on, the ethanol content continues to go up. CO2, there's again a huge spike between day 1 and day 2 as the fermentation kicks off, and then that CO2 is being used up, so it's dropping down, and by day 5, 6, it's down to a level in the area of where it started. The same cells in suspension, ton of cells being produced, especially between day 1 and day 2, and then again, living cells, that is to say, and then again, dropping. That's the cells in suspension, right? So again, they're flocculating out as the fermentation goes on. The pH, right, how acidic the beer is very quickly dropping from the start down to day 2. And then as it finishes up around day 5, there's a slight increase in pH, just a marginal one. And then gravity, of course, that's the one that we all know, depending on how much sugars are in there, they're all getting consumed, and that's just steadily dropping, right, as the fermentation goes on. So that's your that curve, which some of you may produce when you're doing fermentations, is a great one to follow in as much as you have the equipment for it. So again, just to quickly go through it, right? In the early fermentation, the yeast is using up dissolved oxygen. At the very, very beginning, right, there's no detectable uptake of sugars, of glucose. Within about usually 8 to 16 hours, a little bit longer potentially if it's a lager fermentation, you have some signs of active fermentation, and then 24 hours, budding cells are observed, right? The cells are beginning to split off or to reproduce. The temperature rises, and again, you've probably all seen that in your fermentations, that there's a temperature rise. Fermentation is a very heat-generating activity. And then after 28 to 48 hours, the rate of yeast growth and carbohydrates being assimilated into the cells is at its peak. And after 48 hours, the pH falls. And as I said, then there's going to be a little slight uptick at the end of the fermentation. So, we talked just briefly about the difference between ale yeast and lager yeast. I'm guessing that most of you probably are doing ale fermentations primarily, but there may be some of you that are experimenting with lager fermentations. Obviously, it takes a lot more temperature control to do that. Ale is a top fermentation, whereas lager yeasts are bottom fermenting. It's much easier to ferment at a room temperature level. With an ale yeast, a lager yeast, you can ferment at the yeast loves it. The thing with yeast is it loves heat. The problem is that while it's going crazy and having a great time, it's also producing a lot of off flavors and so on. So you can do a lager fermentation at an ale temperature. It just won't taste very good because there's going to be so much off flavors produced, and we'll talk about that later. And obviously there's a lot less, in terms of variety of strains, there's a lot less lager strains out there than there are ale strains. So what's unique about brewer's yeast, and I touched on this earlier, I mean, first of all, cells are budding, right? It's an asexual reproduction. Most brewer's yeast is phenolic negative, not all. And we're sitting in Belgium, which is home of tons of strains that are not phenolic negative. So it's probably the wrong place to say that, but it's true. Stress tolerant, and that is something that is unique to brewer's yeast. Not all yeast can handle a low pH and a lot of alcohol, which is actually why, if you go back in the history of brewing centuries, the whole reason why brewers were able to continue to succeed was that yeast slurry that they ended up with at the end of the fermentation is actually a very unwelcome, area for contamination. There's far more risky contamination areas in a brew, and that's because there's alcohol present, there's not a lot of sugars, the pH is dropped. Most wild yeast does not see this as a welcome home, and most can't survive it. It's not to say that some can't. And then, of course, flocculation. That's the big thing. And just to put that in perspective, these days, non-alcoholic fermentations, beers, are becoming very popular. And a lot of those non-alcoholic strains or maltose negative strains, depending on there's the different approaches, those don't flocculate very well. So it's a whole different game trying to understand procedurally what you need to do to make a beer compared to a traditional fermentation that you can do in a homebrew setting just as well as a pro setting. Oops, over here. Yeah, and of course, as you may or may not have considered, it's always nice to think of strains regionally. It doesn't mean that they have to be, but there is a kind of a characterization when you say an English strain or a British strain. There is a typical characterization that comes to mind, and certainly Belgian strain, even though that's still a wide characterization, but you still, phenolics being a big one in Belgian strains, German strains, right, in terms of lagers and so on, American strains being a lot more neutral, typically, in character. So one of the things that I would, we talk about more and more at White Labs is how do you actually define a good beer? And one of the nice things to do, and some of you may be good at this already, and some of you may have a different approach, is to think not in terms of, well, what is a good beer, as in, oh, it tastes good, I like it, it's sweet, it's less sweet, but in terms of the style that you're going for and what are the characteristics of that style. And that changes the game. As soon as you start thinking in those terms, you can taste a beer which you may not like, but stylistically may be an excellent beer. And I think that's a much more productive way to think about things when you're trying to assess what maybe you're doing or friends are doing or beers that you're tasting, because you can sometimes be fooled into thinking, well, I've tasted a better this or that, but the question, when you turn the question around and say, okay, this is supposed to be this, so what are the characteristics of this? And of course you can download that from the internet, something that says, okay, this is what these characteristics are, running through the malt, the mouthfeel, all that stuff. And that really changes the way you start to think about beers. So stylistic accuracy, the desired flavor and aromas that are there, what is acceptable and what is not acceptable to a style. And that, you can easily Google that and say, okay, this is the beer. What is acceptable, what's not? Obviously, there can be some wiggle room in some beers, and in other beer styles, much less. And then aside from flavor, of course, you're looking at the wort and the fermentation, the attenuation, the flocculation, all of that stuff. And we'll come to that. So this is obviously this is too. You don't need to get into chemistry and biology here, but this is basically what's happening when a yeast cell is metabolizing. Right? You have sugars that are being consumed. You have oxygen, nitrogen, other minerals, and then you have CO2, you have alcohol and you have flavor being produced. And the thing to remember is that when that yeast cell is not happy, then it's always going to be compensating in one direction or another. So the whole trick of doing a good fermentation is to have as much control over what that yeast cell is doing. So that's why, even though you don't need to know the chemistry going on here, it's important to keep this in mind, because as soon as, for example, the temperature is too high from what you would, ideally want it to be, well, what's going to happen there? Okay, the yeast is going to be very happy. It's going to say, oh, there's still sugar. I'm consuming even more sugar. I can produce even more cells. I can produce even more flavor. But flavor, it can also be, as I say, it's not just positive. It's off flavors, right, and so on. So the whole point of hitting that right temperature range is to get that optimal balance between alcohol, CO2, and desirable flavors while minimizing off flavors. So any fermentation, there's basically a number of, call them building blocks of fermentation, right? You need to have source of carbohydrates, malt sugars, amino acids, which is the nitrogen from the malt, minerals, which is again from the malt and from the water, vitamins coming from the malt, and then oxygen, which may be from aeration or agitation. Using dry yeast, you don't really need to add any. The interesting thing with all of these is that anytime you're doing a kind of a normal fermentation, meaning you're not trying to push the boundaries, right? You're doing a pale ale that's 5 or 6%, or 4 or 5%, or a lager at 5%, or whatever the style that you're doing. As long as you're doing something that's kind of in that normal range, all these nutrition requirements will be fulfilled from that malt. As soon as you step away from what you would call a kind of a standard fermentation, then you may need to add more of one thing or another to compensate. Because again, the yeast cells, they will continue to work. They will find ways to compensate. The trick is that all those tons of enzymatic processes that are going on during fermentation, some will be compromised, and that's where off flavors and so on will happen. So basically, that's kind of the key, and I'll talk a little bit in a second here about what to think about. So the first one is zinc. That's probably the most fundamental thing. Most pro brewers will always add zinc, not because it's needed. Normally, there's enough zinc, as I said, from a typical malt fermentation. But if there isn't, so if something happens and zinc is in short supply, it is going to affect the brew. So that's typically why brewers will add a little bit, because it's so cheap, and it just ensures that, okay, if something is not as it should be, there's going to be enough zinc, the fermentation is going to continue. FanMax, or free amino nitrogen, is another one. And again, certain yeast strains really like Kvikes, for example, really like nitrogen. And this is something in the last couple of years, more and more data is showing that free amino nitrogen is a real big influence on fermentations, especially high gravity fermentations. So if you're doing 9, 10, or even more ABV beers, it's a very good idea to look at fan and adding an extra fan. It cuts off many days potentially from fermentation and is a huge benefit to yeast health. So those are two really cheap nutrients that you can just, as a habit, add in, and over time, you're going to have better fermentations just simply by being on the cautious side, you might say. So yeah, right behind me, that's our, some of you may have seen the old format that we used to have. They were a 40 milliliter package that you would tear. So now we have this new 70 milliliter format, so it's almost twice the amount of yeast. You don't need to do a yeast starter. I know some homebrewers love to do yeast starters, some hate it. You don't need to do a yeast starter with this. If you're able to oxygenate, it's definitely a benefit, but it's not needed per se. I mean, we have more and more data showing that you can have a good fermentation without oxygenating, and that's very true for dry yeast, but Traditionally for liquid yeast, it's been more of a question. And yeah, these have a 7-month from production best before date. So 1 pouch would be a normal, 4 to 5 ABV, or 10 to 12 starting Plato, or 1040 to 1050 if you want to talk in gravity. Fermentation, you'd use 1 pouch, and then if you're going up in volume in gravity, 2 pouches, or if you're fermenting cold, 2 pouches, and then if you're going really high, 9, 10, 11, 12% ABV, then you definitely want to go 3 pouches or even 4 pouches if you're trying to brew something crazy. And again, I know home brewers like to try that sometimes. I think that's the same thing. Another thing worth considering or keeping in mind, the more you Google, you'll find a lot of talk about overpitching, underpitching. I can tell you from a yeast perspective, 99% of the problems that we are helping brewers with stem from underpitching, not overpitching. But if you're reading about fermentation and yeast, you could be under the impression that it's maybe it's a 50% problem. That got to be careful not to overpitch, right? To put too much yeast in. I can tell you really have to put a lot of yeast in before you're into that territory. And as I said, more importantly, there's so many problems that come from underpitching. So I would definitely err on the side of overpitching. Do not lose sleep thinking about whether you've overpitched, because really it's so rare that is the origin of the problems that we're dealing with, the poor fermentation issues. So, and again, just to talk briefly about this, when you're Googling, it's so hard to find good information. There's all kinds of homebrew forums. I'm sure you've been on them, and everyone has a million opinions. But there's a few principles that you can keep in mind, and that is, true enough, low pitching rates do produce high cell growth, because you're basically throwing a few cells into a wort that has a ton of sugars, and they're basically having a party, right? They're just going for it. The problem is that, again, it's always this balance that you're trying to achieve in a fermentation, and it won't only be desirable flavor compounds that are being produced. There may be some in certain styles, they may work to an extent, but on balance, it's going to be off flavors that are more off flavors produced the more you under pitch. And then vice versa, a high pitch rate, you'll have a relatively less cell growth, less flavor compounds, which might sound negative, but in fact what you end up with is more happy, healthy cells. Again, if you really overpitch to the extreme, okay, then you won't have enough cell growth, and then you won't have enough flavor. But again, you really need to be pitching to the extreme before this becomes a problem. Temperature. So I said at the beginning, you can go through all the list of flavor characteristics that a good or a bad fermentation may be responsible for, but temperature is really the thing that gives you that control. And the moment, well, I'm going to come to that in a moment, but the moment that you exceed certain parameters, off flavors appear, and I'll come to that shortly. So, just a little bit. Obviously, I think you're quite familiar with this, understanding where your starting gravity is. Something that not all homebrewers are fully aware of or respectful of is the simple fact that as gravity increases, you need more yeast. And it's pretty much, you can pretty much do it on it's not an exponential curve, it's pretty much a straight curve, right? That once you get above 10, 12, 13 Plato, you're starting to create an environment that becomes stressful for most yeast. So you need to pitch more. So probably 50% more once you're up to 15, 16 Plato. Once you're up to 18 Plato, you're probably doubling the pitch rate. If you're going even more extreme than that, you're going to want to triple it. So it's a very simple bit of math. And again, homebrewers often make the mistake of thinking that, okay, this fermentation, it hit the final gravity that I was targeting, because you can pitch quite a small amount of yeast and still hit that final gravity. But it's all those flavor compounds and off flavors that are produced in that process, because the yeast has been very stressed in that situation. So that's why it's not just as simple as saying, right, I hit the final gravity, I'm happy. There will be other side effects if you're not putting in enough yeast. Yeah, and this is just a nice little curve to show. So if you see here, yes, this is obviously from my American counterpoints, 68 Fahrenheit, which is around, I think that's around 19 Celsius, and 75, I think, is around 23 Celsius, if I'm not mistaken. And you can see very clearly that the light blue line is the warmer fermentation. And you can very clearly see that after 96 hours, there's been a significantly faster gravity drop compared to the colder temperature fermentation. And one of the things that we always like to say is, you want the yeast yeast loves heat. I mean, if you put the same yeast, if you give it 28, 29 Celsius, it'll love it. I mean, you'll have a fast fermentation and everything will happen. The thing is, you need to think about it. It's like having a group of teenagers at home. You want them having a good time, but you don't want them having a party. When they have a party, that's when things start to go wrong, right? And that's kind of it's a good analogy for fermentation. The yeast will have a great party at high temperatures, but a lot of things can go wrong, or they will go wrong. So it's all about keeping control of what's happening. And this is a very nice chart. I mean, you don't have to memorize this by any means. This is just a very illustrative chart of what happens. So here's some different compounds that are produced during fermentation. So first of all, ethanol, you can see. Here's these two fermentations that I was referring to earlier. At 24 Celsius, you ended up with around 5 ABV. At 19, 4.75. So similar. You might even say, hey, I like 5. That sounds like a good number. Fair enough. This propanol, yes. But ethyl acetate, this is where it starts to get interesting. So, and this is that solventy nail polish flavor that you may or may not have identified in your own brews or in other brews. So right here you can see there's a threshold. That means what can the average person, how much do you need to have present for the average person to detect it? And at 30 ppms, most people can start detecting ethyl acetate. And here you can see at 19 Celsius, you've got 22 ppms, right? But at 24, and in a homebrew setting, it's very easy to hit 24, right? I mean, we all know that. You're up to 33, and there you've crossed that threshold, right? So this is where temperature becomes such a big player in this. And the same isoamyl, right? That banana that's typical in like a Hefeweizen strain. Again, you can see, okay, there's a small difference, diacetyl small, but going down to the bottom, acetaldehyde, which is this kind of tart green apple flavor. That's very interesting, right? At 19, you're below the threshold, which for that particular compound is 10 ppm. But at 24, you've way overshot it, right? 152 ppm. And these are things, you can't get this back, right? I mean, once you've overshot that, it's there. So this is just to repeat a little bit what I was saying at the beginning about crafting a beer or building a recipe, if you prefer, right? And this was just taking an example of an IPA that, so in White Labs, we have a brewing company in San Diego and Asheville that brews beers primarily for the purpose of pitching different or doing fermentations with different yeast strains, so you can taste the difference on the same base wort with different strains. So here you have, right? Okay, this is an American style IPA. The recipe, okay, there's some pale malt, some Vienna, some white wheat, some wheat, and then you've got some different hops there, right? That all are kind of in style. Well, what should the yeast strain be? I mean, again, yeah, you could use some different ones, but you'd probably typically use an American, maybe an English strain. It's not to say you couldn't use the other ones, but they'd probably be, you're starting to get a bit off style, right? And then the attenuation and so on, right? You want to consider where you want to be. So it's all about choosing a style and then trying to nail that style, as opposed to just saying, oh, I want to do a good beer, maybe this or that or that or that. Of course you can do that, but I think if you really want to learn and improve, I think it really pays off to try to dial in styles and nail a style, as opposed to just a more generic idea of a good beer. Yeah, this is just a few comments on temperature and so on. I'm just going to skip over that. So this is, again, just a few comments. This is getting a little more technical, but again, as you're repeating your brews over time, you can look at, okay, what if I add a bit more nitrogen? What if I add in a bit more zinc? What if I add in a bit more calcium or less? Fermentation temperature, have I controlled it? Should it be a little cooler? Maybe a little bit warmer, and so on. Yeah, STA, not so relevant, but POF, that's the phenolic profile of the yeast, the pitch rate, and so on. So these are all things that you can play with over time. And again, a good tip is don't try to do everything at once. It's very hard because it's always tempting to play with, 3 or 4 variables. But if you can pull yourself back, try to, only change one variable when you're repeating brews and trying different things. You're going to learn a lot more than as soon as you start messing with 3 or 4 variables, you've pretty much lost the learning as such. It doesn't mean you're not going to produce a good beer, but you're not going to understand, okay, what did this variable change? It becomes very, very difficult. And I mean, this is just something that we talk to pro brewers about this all the time, and it's equally relevant for home brewers, which is it's really worth going back to basics. And when you brew a beer, yourself and anyone that's tasting it, your friends, your family, your neighbors, whoever, I mean, if you can get them to just write down what they're tasting in these different categories, and you can just go online and find something yourself. It doesn't matter that you may taste something different than somebody else, and somebody else may have no idea what all these things mean, but everybody can taste something, and everybody can put a word to it. And the more they taste, oh, here's the same beer. This one I brewed a month ago. This one I brewed 3 months ago. Have a taste. What do you taste? Over time, as you collect that data, you're going to start gaining more and more input from whether that's from someone that really can taste all the different flavors and compounds and so on and put words to it, versus someone who can't. There's still a comparison there, and you're still going to learn, and you can't overestimate how much value that can be over time. So, just to conclude, understanding these different variables impacting fermentation will allow you to make a better beer. It's as simple as that. So I think with that, I can conclude. I have a couple of more slides which I can show you, or I can open the floor and for questions. Maybe I'll just see. Does anyone have questions that they would like to put out there?
We talked about the temperature.
Yep.
And fermentation. And with a high temperature, you can develop some off flavors. But how much time does it take to develop it? So if you the temperature in fermentation is not a steady line.
Yeah.
You try to find some
Yeah. So the question is yeah. How variable can temperature be, right? That's kind of what you're getting at, right? Is if it spikes for a brief period of time,
Yeah.
is that a problem? The answer is it depends, and yes. So the golden rule that we always talk about is 3 degrees plus or minus. So anytime that you're exceeding that, you're stressing the yeast, no matter what. So anytime you're able to, so that would be a sort of a baseline, right? If you're at home trying to control your fermentation temperature, however you're able to, whether that's because you can sit the thing in the basement or you have some sort of refrigeration setup, whatever it is, that golden mark is 3 Celsius. That's not to say that you might not like to control it even more closely, but if you can keep it in that, you're creating a lot less stress for the yeast. But again, yeah, the bottom line is that you can see from those graphs how fast fermentation happens. And of course, typically, not always, but it's typically going to be when there's already that heat pressure from the fermentation, right? Where you're going to have those peaks, and that's when everything's really happening. So, yeah, that's going to be very detrimental, right? On day 6, when maybe the fermentation is basically finished and you're about to get it off the yeast, maybe that's going to have maybe less effect, but it's still, there's still going to be something there, right? Because again, you're giving the yeast a little bit more to play with, right? And so you want to avoid it at all costs. That's the bottom line.
A small amount of time and a small amount of negative.
Yeah, I mean that's the thing, because as soon as you give the yeast that, ooh, heat, okay, now we're going to start moving faster and doing more things.
At which temperature should I pitch a lager yeast and ferment around 9 degrees Celsius afterwards?
Oh, what the pitch temperature?
Yeah.
I mean, ideally 9 or 10. Yeah, you would ideally like to pitch it at that temperature. There is, I'm not going to call it a school of thought, let's call it a shortcut that some brewers try to use, where they'll try to pitch at a higher temperature and then very quickly cool. Again, okay, it's a way of kickstarting the fermentation, and maybe you save a little bit of time by doing that, but from a flavor fermentation perspective, you're not doing anything positive. So the best thing is to have that solid, steady 10-degree fermentation temperature, and try to keep it to, again, the +3 rule, maybe rising to 13, but not higher than that.
The yeast doesn't get a shock when I have it before that on room temperature, and I'm giving that.
No, and that's a little bit of a kind of a misunderstanding. I mean, it's of course it's best if you can match the temperature. So it would be great to pitch the yeast at around 9 or 10, but the yeast can handle it. So I mean, if it's sitting at 20 and you pitch it into 9, it can handle it. So and that goes for dry or liquid. Anyone else?
So we saw that the higher temperature can potentially give more off flavors, but a lot of home brewers are saying that after day 1, day 2 of the fermentation, they increase the temperature to avoid the deacetyl.
Yes. So I didn't really talk about a diacetyl rest, but yes, you can do that. And I actually think I have let me see here. Yeah, so look here, forced diacetyl testing, making sure a beer is ready. So the key to, I don't know, I assume all of you know what diacetyl is. Some may be able to pick it up. Some people are very sensitive to diacetyl, others not at all. And interestingly, with diacetyl, people that don't understand what it is will often attribute it or see it as a positive taste, a positive flavor, but it's not. Again, there's a little asterisk. Some styles, for example, certain lager styles can have some diacetyl in them. The trick with diacetyl is, so diacetyl forms, the fermentation finishes, and it's an enzymatic process that the process has to happen in order for those precursors that ultimately remove the diacetyl from the beer. The fermentation has to have produced those. I've lost the word for it, but let's call them the enzymes that are that process that's going to remove the diacetyl. So if you remove the yeast too early, diacetyl will form, but then there'll be no yeast to get rid of it. So that's the whole trick with diacetyl. But there's a very easy way around that, and that is you can just take a little sample of your beer, put it in a water bath, raise the temperature for 10 minutes or half an hour, something like that, and then smell it. Obviously, you need to learn what diacetyl is, so if you don't know it, then you need to either buy a little test kit where you can learn it, or if you know somebody that does know what it is, then have them either smell it or do it. As long as you don't smell any diacetyl on that sample, then that means the beer is ready. And yes, the trick there is that towards the end of fermentation, you can let it rise by about 3 degrees. It's not necessary, it just might, again, you still should do the diacetyl test even if you're holding the temperature steady, because the beer will get rid of diacetyl as long as the yeast is there, whether it's at 10 or 13 or 20 or 23, whatever the temperature, it will still get rid of it, but it will just go a little faster if you do that little free rise, as it's typically called. The process will be accelerated a bit. So yes, you can do that. Anyone else? I will show my last little thing. I had a couple of. Another nice thing that you can do at the start is to do a forced fermentation. So when you have got your wort and you're ready to, you can already have pitched the yeast, but then you can take a small sample with a small amount of yeast. It can be a relatively high pitch to the amount, but I mean, it's just a tiny little pitch, right? So let's just say you have a little thing. And then you can incubate that at room temperature for 24, 48, 72 hours. Take some gravity readings and see where you're going to end up at, and that tells you the potential of that wort, right? That's the potential level of alcohol or the gravity drop that you can get. That doesn't mean that your fermentation is going to reach that, but that's just going to give you an idea of when the actual fermentation, right? When you're whatever 30 or 50 or whatever how many liters of beer you're doing is done. If you've got a match between that forced fermentation and the final fermentation 5 or 6 days later, then you're basically there, right? But if there's a mismatch, perhaps the fermentation's not done. There can also be other factors that have come into play, that contamination or who knows what, right? That has affected that fermentation. But it's always a nice baseline to know, okay, this is kind of this is where I should get to, and then in 5 days you'll see, did I get to that? So it's a relatively easy way to just kind of give yourself a guideline that's specific to the beer that you're brewing. So yeah, that's about all I have for today. Feel free to come up and if you have any other questions, I'm here, so you can come and talk to me after. But thanks for today.